In this video, you'll learn about SQL data types, which are the fundamental building blocks for designing databases. Data types define the kind of data that can be stored in a database column. Each SQL database utilizes specific data types to efficiently store, retrieve, and manipulate information. Let's explore numeric data types in SQL. Common numeric types include integer, also known as int, used for storing whole numbers without decimals. Smallint is for smaller range integers, from negative 32,768 to positive 32,767. Bigint handles large range integers. Decimal and numeric are for fixed precision numbers. Float and real are for approximate floating point values. Here's an example. We're creating a table called products. It includes columns like product ID as int, product name as varchar with a length of 100, quantity as smallint, price as decimal with a total of 10 digits and 2 decimal places, weight as float, and inventory value as bigint. An example insertion into the products table includes a product ID of 1, the product name as laptop, a quantity of 50, a price of 1,299.99, a weight of 2.5, and an inventory value of 64,999. Now let's examine character and string data types in SQL. Common string types include char with a length of n, which represents fixed-length strings padded with spaces. Varchar with a length of n is for variable length strings up to n characters. Text handles variable length strings with no specified limit. Varchar and intar provide Unicode character support. CLOB, which stands for Character Large Object, is designed for very large text. Here is a comparison of how these different string types handle storage and when they are appropriate to use. Char with a length of 10 always takes up 10 bytes of storage and is suitable for fixed codes like zip codes. Varchar with a length of 10 uses from 1 to 10 bytes, which is suitable for names and descriptions. Text uses variable storage and is suitable for longer text like articles and comments. Now let's consider an example where each row represents a string consisting of 3 characters. Char with length of 10 represents the string ABC followed by 7 spaces. Varchar with length of 10 represents the string ABC without any spaces. Text represents the string long text. Let's dive into date and time data types in SQL. These include date, which stores date values in the format year-month-day. Time stores time values in the format hour-minute-second. Datetime and timestamp store both date and time information. Interval stores a period of time. Timestamp stores a timestamp with time zone information. Here is an example. We're creating a table called events with columns like event ID as int, event name as varchar with a length of 100, event date as date, start time as time, end time as time, and created at as timestamp. Sample data being inserted into this events table includes an event ID of 1, the event name company summit, the event date as 2024-04-15, the start time as 09:00:00, the end time as 17:00:00, and the created at timestamp as 2024-01-1015:30:45. Now let's discuss the Boolean data type in SQL. The Boolean data type stores logical values that represent the concept of truth. These values are true, false, and null, which indicates an unknown value. Here are the common representations. True can be represented as 1, the letter Y, the word yes, or the letter T. False can be represented as 0, the letter N, the word no, or the letter F. Here's an example. We're creating a table called users with columns like user ID as int, username as varchar with a length of 50, email as varchar with a length of 100, is active as Boolean, is admin as Boolean, and email verified as Boolean. Sample data being inserted into this users table includes a user ID of 1, the username John Doe, the email john@example.com, is active as true, is admin as false, and email verified as true. A sample query selects all users from the users table where is active is true and is admin is false. Let's take a look at binary data types in SQL. These include binary and varbinary, which represent fixed or variable length binary data. Blob, which stands for binary large object, is used for storing large binary data. BYTA is a PostgreSQL-specific binary data type. Image is a SQL Server legacy binary type that is now deprecated. Common use cases for binary data types include storing files and documents, images and multimedia, encrypted data, and serialized objects. Let's investigate special data types in SQL. These modern and specialized types include JSON and JSON, which are used to store and query JSON documents. XML is for storing and querying XML documents. Enum defines a list of allowable values. Array stores arrays of values. Geometry and geography store spatial data for maps. UUID, which stands for Universally Unique Identifier, store universally unique identifiers. Here's an example using the JSON data type. We are creating a table called product details with columns like product ID as int, name as varchar with a length of 100, and attributes as JSON. Sample data being inserted into this product details table includes a product ID of 1, the name smartphone, and the following JSON attributes. Color is black, storage is 128 GB, and specs list screen as 6.5-inch, camera as 12 megapixels, and battery as 4000 mAh. A sample query selects the name, color, and camera from the product details table. The color is derived from the attributes column in the JSON data. Similarly, the camera is derived from the specs section of the attributes column. Now let's explore database-specific data types in SQL. Here's a comparison across different databases. In MySQL, common data types include TININT for very small integers, mediumint for medium-sized integers, enum for strings with one value from a predefined list, and set for strings with multiple values from a predefined list. In PostgreSQL, common data types include JSON, which is a binary JSON format with indexing support, CIDR INET, and McAdder for network address types, TSQRY and Svector for full-text search types, and point, line, and polygon for geometric data types. In SQL Server, common data types include money and small money for currency data types, unique identifier for GUID/UUID values, hierarchyit for representing position in a hierarchy, and geography and geometry for spatial data types. In Oracle, common data types include number for numeric values with high precision, long and long raw as legacy variable length types, file as a binary file locator, and rowit and eurowit as physical and logical row identifiers. Here are some data type best practices to consider in SQL. Choose the smallest data type that can reliably store your data. Be consistent with data types across tables that will be joined. Prefer fixed length types for frequently accessed columns. Consider database-specific types for specialized data. Use appropriate numeric types for calculations to avoid precision loss. Document your data type choices for future reference. For example, the following comparison table shows how choosing better data types can impact efficiency. A poor choice is varchar with a length of 255 for country code. A better choice is char with a length of 2 for country code. A poor choice is text for short comments. A better choice is varchar with a length of 500 for short comments. A poor choice is float for money values. A better choice is decimal with a total of 19 digits, and 4 decimal places for money values. A poor choice is varchar for true or false flags. A better choice is Boolean for true or false flags. Here is a summary of key takeaways relating to SQL data types. Data types define the nature, behavior, and storage requirements of data. Choose appropriate data types for performance, storage efficiency, and data integrity. Consider specialized data types for specific use cases like JSON, XML, and spatial data. Be aware of database-specific variations in data type implementations. Data type selection impacts database performance, storage requirements, and query efficiency. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.